Alrighty, nerds. Today we are going to start learning, finally, about the reciprocal functions secant, cosecant, and cotangent. Yay, reciprocal functions and their graphs. Big deal. They are a big deal, at least in my opinion. So what do we know? Well, a reciprocal just means you flip a fraction over, right? So cotangent, being the reciprocal of tangent, just means 1 over tangent. Of course, we already know a fractional setup for tangent. Tangent of x is sine x over cosine x. We did that a while back. So its reciprocal, 1 over tangent, is also equal to cosine x over sine of x. Cosecant is the reciprocal of sine. I know that annoys you. I know that you want the reciprocal of sine to be secant, but it's not. The reciprocal of sine of x is cosecant of x. And the reciprocal of cosine of x is secant x. They are each other's reciprocals. So you could also say that cosine of x is 1 over secant x. You could say sine of x is 1 over cosecant x. They are each other's reciprocals. Cool with that? All right. If you struggle to remember which one goes with which, I always tell my students that the reciprocal functions will come in an SC pair. So if one of them starts with a C, the other one starts with an S. I don't know if that helps. That has helped some people in the past to know that secant is the reciprocal of cosine. Now, in our unit circle, and you know what, not even unit circle, because I don't have the unit circle memorized. So in our quadrants, I've told you, I don't know how many times, x, y, r. Big deal, x, y, r. Sine of theta is y over r. Obviously, in the unit circle, that's y over 1. But I do want you to be able to do math the way I do it, and I don't have the unit circle memorized, so I just draw my triangle. So you got your y over r. That means cosecant, the reciprocal of sine, will be r over y. Cosine of theta in the, I don't want to say the unit circle, but in your x, y, r's is x over r. Its reciprocal secant then is r over x. And before I go any further, these two have something that these two do not. And that is discontinuities. Because, not these two, sorry, these two, there we go. These two have discontinuities. Because x and y both have the ability to be 0 on this circle here, which means that both cosecant and secant had the ability to be radius over 0, which is undefined. So these have vertical asymptotes, while their reciprocals do not. Of course, tangent already had vertical asymptotes, so that's not a new thing. Tangent is y over x. It has a vertical asymptote every time x is 0 here. This would be side length x in this circle. But cotangent would then be x over y. Its discontinuities happen every time y is 0 on this. Okay. So there they are. There's your x, y, r's. I do not have these memorized. I have these memorized, and I know which one is the reciprocal of which one. So if you ask me what side lengths the secant use, I legitimately go reciprocal cosine, cosine's x over r, so it's r over x. Is that slower? Yes. But my memory is just not very good. All right. Something else I don't have memorized, but I can work out as I need it, is this table. Sine and cosine have domains of all real numbers. So where are they undefined in the first full circle? Nowhere. They are never undefined in the first full circle. Because both of them have the domain of all real numbers. Like so. Sine and cosine have the exact same range. What's their ranges? -1 to +1. And then we had tangent. Since tangent is y over x, and x does have the ability to be 0 in our unit circle, tangent does have the ability to be undefined. So you look up at your unit circle and you ask yourself, where would x be 0 as far as angles are concerned? Where would I need to be on here for x to be equal to 0? On the y-axis, yeah, because this isn't our xy plane, but if we were here, we clearly have no x value, which you can see right there. So at pi over 2 and 3 pi over 2, tangent tries to divide by 0. So it is undefined at, and we're going to do these as theta equals, not x, because I don't want you confusing side length x with variable x. So we do thetas. Tangent is undefined when theta is pi over 2 and also 3 pi over 2. Oh, so then what is its domain? Its domain is everything except for the 1, 3, 5, 7, 9, the odd multiples of pi. We've done that before. How do we say everything but the odd multiples of pi? Well, you say theta better not be. You pick the first odd multiple of pi and then go period length. And what's the period of tangent? Pi. So you can go pi left or right any number of times. Say, do I usually write in pi or pi in? I can't remember. Pi in? Okay. There you go. In pi, pi in. They mean the same thing. This is obviously if n is an integer, which includes 0. 0 is an integer. Do you guys remember what the range for tangent is, though? All real numbers, because it goes up to positive infinity and down to negative infinity. So we have all real numbers because it has infinite discontinuities. All right, now the reciprocal functions. Cosecant is the reciprocal of sine. Sine is y over r. I'm just going to write that, y over r. So cosecant is r over y. Oh my goodness, that has discontinuities. That will be undefined when y is 0. So if you look back up here to this unit circle, where on here is y equal to 0? On the x-axis, which would be 0 and pi. And we're not going to include 2 pi because it's got parentheses. So we are undefined when theta is 0 and pi. And then it would again be undefined at 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. These seem to be the whole multiples of pi. So theta better not be pi n. Again, where n is an integer, and since 0 is an integer, this includes 0 as well. So any positive or negative or 0 multiple of pi. But the range is something that's a little bit more tricky. The range is going to be made up by the outcomes of this fraction. So I don't want to say the y values because that's confusing, but the outcomes of this fraction, correct? These are side lengths of a triangle. In the triangle, length y, what is the maximum size that could be? Well, that's in the unit circle. But in general, its maximum length is r. Yes? So in any triangle, of course it wouldn't be a triangle if they were equal, but we do know if we were drawing on here, y is less than or equal to r, always. And so let's just talk about positive y's for now. If y is less than r, but still positive, doesn't that allow y to be something insanely small, like 0.00001? And if you have insanely small things in the bottom, what value does your fraction tend to approach? Oh, that's the top. If the top gets close to 0, but if the bottom gets really, really small, then the whole value of the fraction becomes really, really big. How many pennies fit into $1 million? A lot of them. So the smaller the denominator gets, but still stays positive. Let's say the smaller its absolute value becomes. The smaller the size of the denominator becomes, the larger the value of the fraction. And as long as we're talking positives, the smallest value this could take on would be when r and y have the same size. So this thing's positive range is 1 to infinity. Guess what the other size is? Or the other side, excuse me. Negative infinity to negative 1. Yep. Inclusive. As it turns out, the reciprocal of 1 is 1. That's why sine and cosecant both hit y equals 1. The reciprocal of negative 1 is negative 1. That's why sine and cosecant both hit y equals negative 1. Isn't that crazy? This thing's range does not include any of the numbers between the maximum and the minimum of sine. Yeah. It's like it points the exact opposite direction as sine does. And guess what? Secant is going to behave the exact same way as this did. Because secant and cosecant are just reciprocals of sine and cosine. And since sine and cosine have the same range, secant and cosecant have the same range. So since I'm still holding the green pen, I'm just going to go ahead and fill that out. But their domains are different. And the reason why is because secant being the reciprocal of cosine, cosine being x over r, secant is r over x. This is side length x, not variable x. So when side length x is 0, secant is undefined. So if we look back up to here, where on here would side length x be equal to 0? Pi over 2 and 3 pi over 2. Oh, you mean the exact same place the tangent is undefined, which should make sense because tangent is something over cosine, just like secant is something over cosine. So the domain for secant is the exact same as the domain for tangent because they're both over cosine. Or as far as the side lengths are concerned, they're both over x, side length x, not variable x. So yeah, secant and tangent have the same domain. The input had better not be equal to any of the odd pi over 2's. So if tangent and secant have the same domain, what do you think cotangent would have the same domain as? Cosecant. And it does. But why? Well, cotangent is x over y. Cosecant is also over y. So anytime cosecant is undefined, so is cotangent, because you can't divide by 0. Anytime side length y is 0, your function will be undefined, either cosecant or cotangent. So yeah. Do I have any of this memorized? Sure don't. I know these, sine, cosine, and tangents. I know they're x, y, r's. And then I can build everything else from that. Less efficient as far as time is concerned, but it's much more efficient as far as brain space is concerned. So it's the same exact domain. Theta, the input, had better not be, what's on my paper, something orange, had better not be any whole multiples of pi. But just like tangent, cotangent's range is all real numbers. There. All kinds of fun on that table, huh? I know that stuff. That's what I know. And it's mostly because of that stuff. So these are now input x, output y. These are no longer side lengths x and y. Okay? So here we have angle x and ratio of side lengths y. I'm just trying to separate the x's and the y's from the unit circles x's and y's. But what is the reciprocal of y equals cosecant of x? Y equals sine of x. guess what? I do not know the graph of cosecant x. But I do know that it is the reciprocal of sine of x, and I do know the graph of sine of x. So here's what I'm going to do. Every time I need to graph a cosecant, I'm going to graph its reciprocal sine wave as a dotted line. Not only does it make it so I don't have to memorize the graph of cosecant, it also strengthens my graphing sine wave skills. Sine starts at the midline and then heads up and has a period length of 2 pi. Its maximum is 1, its minimum is -1. And since sine is an odd function, I know that it has the exact opposite behavior as I go to the left. That is a really good sine wave. You see that thing? It's gorgeous. God, I'm good at this. Now, we're talking about the reciprocal of what I just drew. Yes? Notice then that every time this graph touches the midline, its y value is 0. So if sine has a value of 0, 1 over sine has a value of 1 over 0, which is undefined. So every time this sine wave hits its midline, the cosecant graph, it's not a wave, is undefined. So unfortunately, I can't say cosecant wave. I can't say secant wave. And just like tangent, secant nor cosecant has a midline or amplitude. Goodbye, dangle. Anyway, there it is. And I do have a vertical asymptote on that y-axis like that. So our domain is everything except for whole multiples of pi. And we've already said that out. Now, since they're x values, they're angles x, I can actually say x cannot be in pi. Or what do I say, pi in or pi in? Pi in or in pi? Pi in? Crap. I don't know. I can't remember because they mean the same thing. I know I already asked, but I already forgot. There we go. The range. Well, we've already written that down. It goes from negative infinity to -1, and then from 1 to infinity. Because as it turns out, the reciprocal of +1 is +1, and the reciprocal of -1 is -1. The asymptotes are the x's that the domain can't be. So that's kind of a redundant thing to write, but let's just go ahead and do it. And we know that it goes up to infinity and down to negative infinity, so it actually looks like this. Essentially, the cosecant graph takes all of the concavity zones and flips them upside down. It's almost like the graph got snapped right here and we turned its bumps the other way. That's weird, huh? But that's how it works. The good news is, if you can graph a sine wave, you can graph cosecant. Regardless of the transformations. If I throw just an ugly cosecant graph your way, all you have to do is graph the reciprocal ugly sine wave and you're golden. And that exact same trick works for secant. Secant's reciprocal is cosine of x. Y equals cosine of x. I'm going to go ahead and put the parent cosine wave on here as a dotted line. Oops. Uh-oh, look what I've done. I put it on the wrong box. Schmeckle. How did I do that? How did I do that? Unreal. Hold on. I'm swapping to another set of notes. Okay. So this is just another pack of notes. So don't mind the discontinuity in the video. It's just I'm doing that. Okay, because I screwed up. So we'll just slide that one out of there. You already had this one. Remember, it's this stuff. Yeah, you got it. Okay. So this time I'm going to try to draw this in the appropriate box. I'll be okay. The maximum for cosine is 1, and that matters to us because cosine starts at a maximum. And its not amplitude, its period length is 2 pi, just like sine, so it's going to begin and end there. Halfway between the maximums is a minimum. Halfway between min and max is midline. And then same pattern going the other direction. There we go. All right. All the major crap ups are now done. Domain. Well, look, cosine of x has the ability to be 0. So every time cosine of x equals 0, I am breaking the domain of its reciprocal. So its domain is going to be everything except for when cosine hits its midline. Oh boy. Just like cosecant, secant has an infinite number of vertical asymptotes. But these are not on the whole multiples of pi. These are on the odd multiples of pi over 2. And what color did I use for that one? Before I used red for domain. So you say this, x had better not be pi over 2 plus pi n. And of course, this is still for n being an integer. But just like cosecant, the range of secant is negative infinity to negative 1. And from 1 to infinity. The asymptotes are all the numbers that the domain cannot be. They will occur at every odd multiple of pi over 2. The reciprocal of 1 is 1. The reciprocal of negative 1 is negative 1. Therefore, the secant graph is basically the exact same idea as the cosecant graph. It takes the concavities of cosine and flips them upside down. Also, just like how every sine wave can be written as cosine and every cosine can be written as sine, every secant can be written as cosecant and every cosecant can be written as secant. All you have to do is shift them. Guess how far? Half of a pi, pi over 2. Why pi over 2? Because 90 degrees, that's why. Because secant and cosecant are complementary functions, that's why one starts with co. So it's just like sine and cosine, how you shift pi over 2 and you got the other graph. Ta-da! Fine. We're ready to do some examples. Can I answer any questions before we do some examples? No? Scoot. It says use transformations, graph each function, its reciprocal, state the period, show all asymptotes. Okay, whatever. Let's start with the most important thing. Reciprocal. The reciprocal of cosecant is sine. So the reciprocal function will be y equals 2 sine of, and I don't want to say x over 2. How about I say 1/2 x? Because that's going to make the period length easier to find. Because the period is 2 pi over b. For us, that's 2 pi over 1/2. Period length, grand total of 4 pi. I'm going to graph a ghost sine wave as a dotted line. It's going to have an amplitude of 2. Midline's the x-axis with a period length of 4 pi. It'll begin at the origin. It'll end at 4 pi. Halfway between the beginning and the end, since it's a sine wave, will be another midline hit. Up to my max, down to my min, and same thing going the other direction. Every time that ghost wave hit its midline, I know I have a vertical asymptote for cosecant. And then just turn its bumps upside down. So can other math teachers graph that faster than me? I'm sure they can, because they've memorized a bunch of stuff. But I try not to memorize things. I need that ghost sine wave. No shame in my game. No shame in my game. Nope. What do you think? Can you guys do that? I felt like you were pretty good at graphing sine and cosine. That means you should be pretty good at graphing secant and cosecant. Yes, ma'am.
So for the reciprocal, you just switch like when you rewrite it, basically just switch out the cosecant for sine.
Just switch the trig type. So its reciprocal is just the reciprocal of cosecant would be sine, and this one reciprocal of secant will be cosine. Yes, Mark. That's what it is. The inflection points. That's why I said it turns all the concavities upside down. So yeah, the asymptotes will always occur at the inflection points. So what that means then is secant and cosecant, neither one of them has a single inflection point. Neither one of them has a single inflection point. Isn't that neat? Like I said, this is going to be y equals reciprocal function -2 cosine of 3x. Once again, the midline for the reciprocal function will be the x-axis. But the period length, 2 pi over b. This b value is 3, so I have a period length of 2 pi over 3, which would normally be difficult for us to deal with, but check this grid out. It went by pi over 6s, which is going to make life very good. This is a negative cosine wave, meaning it's going to begin at a minimum, and the amplitude is 2. So it's going to begin at a -2, and at 2 pi over 3, it will be back to that minimum. Halfway between the minimums, it'll be at its maximum of +2, and halfway between min and max, midline. Then you could just repeat the process. Anytime that reciprocal function hit its midline, secant is undefined. Then just turn the bumps upside down. Wee. Yo. Wow. A lot of cycles of that wave. Well, crap. Secant and cosecant aren't waves. See, it happens. They're just functions. They're like tangent and cotangent, how we can't say they're waves. We just say it's a function. Sine and cosine are the only true waves, and sine and cosine are the only ones that actually have a midline. Sine and cosine are the only ones that actually have an amplitude, so on and so forth. Questions, comments, concerns about secant and cosecant so far? Not bad, right? Not bad at all. I hope you think that it's not bad at all. What's next? Is it cotangent? Yes, it be cotangent. Now, cotangent is the reciprocal of tangent. Tangent is y over x. Cotangent, therefore, is x over y. Do not be confused with these. This is angle x and ratio of side lengths y. In the unit circle, though, we're talking about x over y, right? We said that this will be undefined every time y in the unit circle is 0. and y is 0. You know what? Why do I keep saying that? I would just draw it. Pi over 2, pi 3 pi over 2. Okay, there we go. On this unit circle, you have no y length when you're on the x-axis. Those would be angles 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, all of the whole pi's. All the whole pi angles, you have no side length value of y. That means cotangent is undefined at every whole multiple of pi. Just like tangent, halfway between every asymptote, well, halfway between every set of asymptotes, you will find the midline, the middle line, the line that cuts the tangent graph in half. It's also going to cut the cotangent graph in half. Essentially, all of the odd multiples of pi, that's here and here. This, in your unit circle, you have no x side length. So the x side length is 0, making the value of the ratio of sides 0. Now, I'm not going to draw what looks like my tangent curves. And here's why. Right here, if I was at pi over 4, what kind of triangle is that? What side lengths? 1, 1, root 2, right? So what is the value of tangent there? It'd be 1. Value of tangent is 1 when the x and the y have the same side. Well, what's the reciprocal of 1? 1. So just like tangent, cotangent is 1 at pi over 4. And just like tangent, cotangent is negative 1 at 3 pi over 4. And since the period length is pi, we get this. It's essentially a shifted, reflected tangent graph. Every tangent wave can be, crap, I said wave. Every tangent graph can be written as a cotangent. Every cotangent can be written as a tangent. You just have to shift it and reflect it. We good? Makes sense why it's like that? In quadrant 1, tangent and cotangent are both positive. There's quadrant 1. In quadrant 2, tangent and cotangent are both negative. There's quadrant 2. And quadrant 3, and then quadrant 4. So same plus minus behavior, but the asymptotes are in different places. Domain then, well, you could see everything it can't be. So I'm going to do domain and asymptotes at the same time. The domain is angle x. You know, we could say theta if you want to. You want to do theta instead of angle x? Okay. Domain is theta better not be equal to whole numbers of pi. The asymptotes then, but you see the problem with saying domain, the problem with saying the domain is theta can't be, is that asymptotes are always or x equals in order for them to be vertical. So all your asymptotes are going to occur when x equals the numbers that the domain was not allowed to use. The range is just like tangent's range. You could see it. It's all real numbers, negative infinity to positive infinity. Its x-intercepts are, oddly enough, they're all the places where tangent would have been undefined. Isn't that neat? When tangent is undefined, cotangent equals 0. When tangent equals 0, cotangent equals undefined, and vice versa. So its x-intercepts are all of the odd multiples of, I'm going to use x equals since it says x-intercepts. It has odd symmetry. Oh, check out its y-intercept. Jokes, it doesn't have one. Because you're not allowed to use side length x equals 0. It has odd symmetry. That means that cotangent, cotangent of negative x is the same as negative cotangent of x. So tangent, cotangent, and sine all have odd symmetry. Cosine and secant are the only ones that are even. Oh, so since sine is odd, so is cosecant. So you have sine, cosecant, tangent, cotangent are all odd functions. Cosine, secant are the only even functions. We okay? It's not bad, I hope. Again, I feel like you guys are pretty darn good at graphing. It astounded me how little graphing you guys did on the last test, though. If you're so good at graphing, you should use graphing to your benefit. Do it as much as possible. Speaking of graphing, ta-da! Yay! Alrighty. Period length. Remember the period of tangent and cotangent are both supposed to be pi. So our period length is pi over b. This b value is 2. So we have a period length of pi over 2. Cotangent, because I don't have my unit circle memorized, when I have to graph a tangent or cotangent, instead of memorizing where asymptotes and whatnot are, I'm not gonna lie, I do something like this on my paper and then I point at it, and then I go, okay, this cotangent is the reciprocal of tangent. So if tangent's y over x, this must be doing x over y. And of course, these are side lengths, x and y, right? So I come here and I look at 0. And I go, at 0, I have no y length. Oh, this graph is undefined at 0. That is literally how I do it because I don't like to memorize things. And now I know every period from there, I'm going to have another vertical asymptote. And that's going to be same going left and right. The graph has not been shifted up or down. That means the x-axis is still going to be all the places where I have a value of 0. I have not done any reflections, and I have no vertical stretching, so it's going to look like this. There are a lot of periods of this cotangent on this graph. I feel like I didn't need to draw them all. If I was editing my videos, I'd put a time lapse on that. There you go. What's that? Yeah, it's some time lapse music, and it's like, you know, all the waves just show up on the screen. All right, so period length. Oh, you know what? I'm aware that this doesn't have a true midline, but look, it's been shifted up 1. So I am going to go ahead and I'm going to put a green dotted line at +1. We just won't call it a midline. It's the line that goes through all the inflection points. It's a freaking midline. I don't know why we can't say that, but whatever. Whatever. Period length is going to be affected by this horizontal stretch or shrink. We've got a horizontal dilation here. Period is going to be pi over b. Period is pi over pi halves. Ew. So that's pi times 2 over pi. Oh, at a period of 2. Oh, all right. And I could see this graph which shows me that I'm undefined on the y-axis, and since I didn't do any horizontal shifting, that's still going to be true. So I cheated a little bit because I had a graph to look at. And now every 2, I'm going to have another vertical asymptote. Halfway between every pair of asymptotes, I will be on that middle line. And it's been reflected. So that means it has more of a tangent shape to it. And since it's odd, it doesn't matter which reflection it was. They get the same result. Cue time-lapse music. I should do one of those things with like snap and all the grids are there, all the graphs, you know, like you see on YouTube. There you go. Is there anything I can help you with? Any questions you have for me so far? Or is it all making sense? Reciprocal functions, especially secant and cosecant. You're comfortable using their reciprocals as ghost waves? Yeah, you know, the dotted cosine wave and the dotted sine wave, my ghost waves. That's just why I call them. Yeah. All right. Well, appreciate it, nerds.